Hello, my name is Keshwani. This Keshwani, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 276, and today is our lesson number 22. Problem number 17 is what we're going to do. Problem 17. It says if n plus k equals m, how much is k? Very simple, very straightforward question. How much is k? The first statement tells us that n equals 10. Well, n equals 10 is great, but what about n equals 10? That's great, but what about m? Without the m, we cannot figure out the k. Just simply telling us that n equals 10 is useless information. It's useless information. It doesn't help us answer the question how much is k. A, D, B, C, E. If you still do not know what I just did here, A, D, B, C, E, you hear me say this all the time, watch the introduction, GMAT data sufficiency intro, and you will understand the method, the strategy behind how to do these data sufficiency questions, and you should follow that method in every single data sufficiency problem. Just follow it, make it a habit. So first statement does not work, which means answer cannot be A, it cannot be D. Answer has got to be either B, C, or E. Let's look at second statement. The second statement tells us that m plus 10, is that what they tell you? M plus 10 equals n. Alright. So let's bring n to the other side, subtract n from both sides, and subtract 10 from both sides. So we get m minus n, this plus 10 and minus 10 is going to cancel out, and that equals this plus n and minus n is going to cancel out, equals 10. There you go. Voila. The question was how much is k? I don't know what I'm doing here. Why did I do this thing? We're looking for m minus n. Oh, there you go. K. There you go. From here, we know that k equals m minus n. M minus n. And we just found that m minus n equals negative 10. Therefore, the k must be negative 10. So second statement is enough. Second statement does enable us to answer the question. Second statement works. Therefore, the answer is B. The answer is B. That's it. That was it. Let's work on the next one, number 18. The first statement by itself did not do anything, but second statement was actually very straightforward. Number 18. Again, turn to the page 276 and read the question to yourself. It says the number of seats in the first row of an auditorium is 18. Alright. So the first row is 18, and then they go on to tell us that each row after that, each row after the first one is 2 more than the previous one. Let's understand first, what does it mean? Each row after that is 2 more than previous one. Question is, what are the total number of seats? Total number of seats. They want us to be able to tell what are total number of seats. Before we look at the two statements that they give us, one by one and then together if we have to, whatever. Before we do that, let's first understand this part. Each row after the first one is 2 more than the previous one. For example, here they tell us the first one is 18. The next one is going to be 18 plus 2, which is 20. The one after that is going to be 20 plus 2, and so on and so forth. It's going to be 20 plus 2. one after that is going to be 22 plus 2, and so on and so forth. Question is, how do we express that in terms of symbols? Well, let's use f for the first one. That's the first one, f. And this 2 that you see there, each time this goes up by 2, each time that it goes up by 2 is the difference between the number of rows in the number of seats in the two adjacent rows. And the difference is 2. Let's call that difference d. D here is 2. Again, d represents the difference in seats in the two adjacent row. Difference in the number of seats in two adjacent rows. As you go higher up in the row, they go up by 2 each. So the next one is going to be f plus d. The one after that is going to be f plus d plus a d. One after that is going to be f plus, you see, f plus 2d's plus a d. As you can clearly see here, the d is 2. 2 times 2 is 4. You see here, 18 plus 2 times 2, which is 4. That gives us the 22, which is what you see here, plus d, which is your 2 again. The question is, how do we find out the number of seats in a given row? Which is very simple. This is how we do it. F plus, you see, the first one is only f. Second one is d. So it's not 2 times d, it's just d. The third one is not f plus 3d's. Third one is f plus 2d's. The fourth one is, this is our first row, this is our first one, this is our second row, this is our third row, this is our fourth row. Now notice what happens. The first one is just f. The second one is f plus d. It's not f plus 2d. The third one is f plus 2d's, as you can see, f plus 2d's. The fourth row is f plus 2d's plus a d, that's a 3d. F plus 3d. So the formula is f plus n minus 1 d, where n is the number of row, where n is the number of row, or rather row number is what I meant to say, is the row number. For example, for the very first row, watch what happens. For the very first row, it's going to be f plus, since the very first row, n is going to be 1. 1 minus 1 times d. 1 minus 1 is 0. So this whole thing just drops out, and it's just f, which is what this is. It's very important to understand that part. Otherwise, otherwise we will not be able to answer this question. So let's look at the first term, and that's it. We are done. So for a given row, the formula is going to be f plus n minus 1 times d. Even though in reality, we didn't actually have to do this out to understand that thing, because we could actually do it manually, as you can see, as you will see in a second here. Here they tell you that we have 27 rows. The first statement tells us there are 27 rows. There are 27 rows. Well, if there are 27 rows, you can do out manually and figure out how many seats there are. You're going to have to just do 27 times. You're going to have to do 18 plus 20 plus 22 plus 24, and just keep on going, keep on going. This is the first one, second one, third one, fourth one. Keep on going until you reach the 27th row. Until you reach the 27th row, find out the number for that guy. Each one of them goes up by 2 units. Each one of them goes up by 2 units. Find out what the final amount is going to be for the 27th rows, and add them all up manually. It will take us a long time to do it, but it can be done. So knowing that there are 27 rows is enough. We can answer the question. The question is how many seats there are, and knowing that there are 27 rows and each row goes up by 2 seats each time, Obviously, as long as we know the number of rows, we can add them up. 18, 20, 22, 24, 26, 30, and so on and so forth, until we get to 27th row, add them all up, and that's our answer. It can be done. First statement by itself is enough. A, D, B, C, E. Now that we found out that the first statement by itself is enough, the answer cannot be B, C, or E. It's got to be either A or a D. Let's look at second statement. Let's look at second statement. The second statement tells us that last row has 70 seats. Last row has 70 seats. Well, of course, if we know that the last row has 70 seats, the one before it must be 68, the one before it must be 66, the one before that must be 64, and so on and so forth. We can work backwards until we get to number 18, which is our first row, and we stop at that because there are 18 in the first row. One more time, it can be done. This problem can be done manually. It will take a long time doing it manually without the algebra, but it can be done manually, arithmetically that is, as opposed to algebraically, which is knowing that the last row had 70 seats, the one before that will have 68 seats, the one before that will have 66 seats, 64, 62, 60, 58, so on and so on and so forth, until you reach 18, and then you stop and you add up all the seats, and that will tell you how many seats there are in the theater. So it's enough. Second statement is enough by itself. Since the first statement by itself was enough, and since the second statement by itself is enough, the answer is D. That's it. Now, as far as this problem is concerned, in the real exam, the amount of time that we spent coming up with this formula here for a number of seats in a given row, this tells us number of seats in a given row. The work that we did to come up with this formula was not actually necessary, and the work that we are about to do is also not necessary. We have already answered the question. The first statement by itself is enough, and so is the second statement. The work that we are about to do is just purely for the learning purposes, which is I want to actually find out if the two statements actually substantiate each other. Let's take a look at it. The first statement tells us that there are 27 rows. In the first statement they tell us that 27 rows, which means the last row will have, we know the formula, it's going to be F plus n minus 1 times D. The first row has 18 seats, there are 27 rows altogether, so it's 27 minus 1, and the difference between each row is 2. So 18 plus n minus 1 is 26. 26 times 2. 26 times 2 is 26. 25 times 2 is 50. So 26 times 2 must be 52. And guess what we get? 52 plus 18. What do you know? We get 70, which is exactly what the second statement told us. Second statement told us that there are 70 seats in the last row. The last row being the 27th row. The 70 seats in the 27th row. You see, the information that they give you in the first statement and the second statement, they always substantiate each other. They never contradict each other. If the first statement tells you, if you do the work based on the first information based on the first statement, and you find out that there are 27 rows, then the work that you're going to do based on the second statement is not going to give you 26 rows or 25 rows. It's going to be exactly the same number of rows. And if they're not, then something has gone wrong. Something is cuckoo. It's your mistake. You find that mistake. Let's take a look at it. See what happens if we start out with the second statement. And see, let's see if we arrive at the first statement by starting out at the second statement. Here, we started with the first statement. We arrived at the second statement. Now let's start with the second statement and see if we can make our journey back. Second statement tells us that the last row has 70 seats. Well, we know this is the formula. F plus n minus 1 times D represents the number of seats in a given row. This amount equals 70 for the very last row. we know what f is. F is the number of seats in the first row, which is 18. Let's put it in here. 18 plus n minus 1, and we know what the difference is in each row, which is 2. Let's solve for n. N will be the number of rows in the theater. Let's see what happens. Subtract 18 from both sides. So n minus 1 times 2 equals 70 minus 18. 70 minus 20 is 50, so it's 52. So 2 times n minus 1 equals 52. Let's divide both sides by 2. And n minus 1 equals 26. Therefore n equals 27. What do you know? 27 rows. You see? Whether you start with the second statement and prove that you arrive at the first statement, or you can start with the first statement and show that you can arrive at the second statement. It's the same story. Story does not change. It is just a matter of how the story is being told. Assuming that the story is being told, because sometimes the statements don't tell you anything. But here we are claiming that both of the statements by themselves, each individual statement by itself is enough. Therefore, whatever is told in the first statement has to substantiate what was told in the second statement. They will either substantiate each other, or they will not tell you anything at all. They will be useless information. That was it. The answer here is D, because each statement by itself is enough. Okay? Bye now.